Welcome friends to my YouTube channel. Now in today's lecture I shall going to start a new chapter, that is the collision of particles. Okay, that is our today's topic is collision of particles. Now here the first question arises, what is collision? Okay, now a collision is an event in which you can say two or more colliding bodies exerts a force on each other, and due to this there is a change in energy and momentum. Okay, suppose this is an object and this is an object. This moves in this direction and this moves in this direction. That means two objects are approaching each other. So when they collide, so a force for a short time interval comes into play, due to which there is a change in energy and transfer, due to which there is a change in momentum and energy. Okay, so here two or more colliding bodies exerts a force on each other, due to which there is a transfer of energy and momentum. Okay, so this is basically a collision. Okay, now here one thing I have to say, that there are different possibilities. That means the first possibility is that after collision it is possible that the both objects are moving in same direction. Okay, so the first possibility is that after collision the two bodies moving along same direction. Okay, that is in carom board is a plane. So uh, whenever we strike the striker, so it is possible that after striking that particular you can say object in the carom board, the striker and the object moves along same direction. So if after collision the two bodies moving along the same direction, we can say the collision is one dimensional. Okay, so remember this. So after collision, if the uh, target and the striker move along the same direction, that is along the same line, it is called 1D collision, one dimensional collision. And the another possibility is that after collision the striker and the target both can move along different directions. Okay, this is also a possibility, that after collision the target and the striker can move in different directions. So this is 2D collision. Okay, after collision, if two bodies move in different direction, it is called 2D collision. Okay, so this is another possibility, that is if the target and the striker moves along same direction, we can say this is one dimensional collision. But if they move in different directions, okay, we call it 2D collision. Okay, so this is simply 1D and 2D collision. There are two possibilities. Okay, now we can classify the collisions into two categories. Okay, we can classify the collisions in two categories. There are two types of collisions. The first one is elastic. So what is elastic collision? You all know that in collision process we can generally apply the two laws. One is law of conservation of energy and the other is law of conservation of linear momentum. So in elastic collision, the law of conservation of linear momentum as well as the law of conservation of energy both holds good. Okay, so that means energy conservation, energy and linear momentum conservation both holds good. So in this type of collision, we can say this type of collision is elastic, where both the law of conservation of linear momentum and the energy holds good. Or you can say in this type of collision there is no loss of kinetic energy. Okay, there is no loss of kinetic energy. That means simply we can write initial kinetic energy, this equals to final kinetic energy. Okay, so simply we can write, since there is no loss of energy in this case, so initial kinetic energy, this equals to final kinetic energy. Now what are the examples of elastic collision? That you already know, that while learning the kinetic theory of gases, we assume that the force of attraction between the ideal gas molecules is elastic collision. That means the gas molecules, ideal gas molecules, when collide with each other, this collision is perfectly elastic. Okay, so ideal gas molecules suffer elastic collision according to kinetic theory. According to kinetic theory of gases. Okay, so this is one example. Okay, and the another example, we can say that the force of attraction between the proton, electrons and neutrons, that is the these collisions are elastic. Okay, that is collision between atoms or molecules. Okay, this we can say these are the elastic collisions. That is collision between the atoms or molecules, or you can say the collision between electron, protons, neutrons, these are the elastic collision. Okay, so this is what about elastic collision. Here both energy and linear momentum conservation holds good, and since energy conservation holds good, we can easily say that there is no loss of kinetic energy. So initial kinetic energy of the system equals to final kinetic energy. An example, the standard example we take here, the force of attraction between the gas molecules, or you can say the ideal gas molecule suffers elastic collision. Or another example we take, that is the collision between the atoms or molecules, that is electron protons. Okay, okay, these suffer elastic collisions. Okay, now the second type of collision is inelastic collision. Okay, now we shall discuss the second type of collision, that is called inelastic collision. What is it? Remember, here the law of conservation of linear momentum holds good, but energy conservation does not hold good. Okay, here law of conservation of linear momentum holds good, but energy conservation does not hold good. Or we can simply say that law of conservation of linear momentum holds good in two collisions, but in elastic collision law of conservation of energy holds good, and in inelastic collision energy conservation law does not hold good. Okay, so maximum collisions occurring in nature are inelastic. Okay, so maximum collisions occurring in nature are inelastic collisions. Okay, so maximum all the collisions are occurring in nature are inelastic. Okay, here the energy conservation law does not hold good. Okay, now there is another type of collision we can say, that is perfectly inelastic collision. Perfectly inelastic collision. Okay, so what is perfectly inelastic collision? Here what happens, suppose this is a body, these two bodies collide each other. So what happens here, after collision both the objects combined and move together with a common velocity, that is both the two objects combined and move with a common velocity. Okay, so what happens in a perfectly inelastic collision, after collision the two bodies joined and move with a common velocity. Okay, so after collision two bodies join and move with a common velocity. Okay, so this is a here one thing, in perfectly inelastic collision the energy loss is maximum. Okay, there is maximum energy loss. Okay, so there are different type of collisions that I discuss. Okay, now one thing I have to told, one thing I have to tell, that what is scattering. Okay, kindly ignore the noise which is coming from outside. So what is scattering? So this is a special type of collision we can say, where the nature of the body does not change after collision. Okay, nature of the body does not change after collision. Okay, so here nature of the body does not change after collision. Okay, that is, we all know that suppose there is a target at rest and a striking particle is coming towards, so after collision what happens? The incident particle scattered and the target particle recoiled in this direction. Okay, you all know this is scattered and this is recoiled. Okay, suppose there is a target element placed here and the incident particle is striking that particle. So what happened? After collision the incident particle scattered at some angle. Okay, and the target particle recoiled in another direction by another angle, say this is theta and this is phi. That means now angle that the scattered particle makes with the original line is called scattering angle, you all know, and the angle that the original line makes with the recoiled uh, particle is called recoiled angle, that you all know. Okay, we will discuss it in later more descriptively. That is, the familiar example is the scattering of alpha particle by helium nucleus. Okay, the famous example, that is the scattering of alpha particle by atomic nucleus. This is scattering. Okay, so if an incident particle strikes a target after collision, the incident particle scattered at some direction and the target will recoil in another direction. We will see, we just saw this in Compton effect. Okay, so we will discuss it later. So what happens in scattering, the nature of the particle does not remain changed, so it is a special type of collision. And forever, one can also say, when a comet passing through the solar system, the comet is scattered by the solar system. Okay, it is also an scattering. Okay, so in today's lecture I shall discuss about the elastic and inelastic collisions. Okay, and basic idea about scattering. So in our next class I shall going to discuss the law of collisions and one-dimensional collisions. Okay, so video link will be given in the description box. If you have any query, then just write it in comment section. Okay, thank you.